Hello everyone. Hey guys. Today we are having a discussion over the acidic and basic character of oxides and oxyacids. Okay. So basically what does this mean? What this session is all about? If I ask you CaO, calcium oxide, whether it is acidic or basic, how will you tell? If I ask you carbon dioxide or silica dioxide, which is SiO2. So how to determine that whether these are the oxides which are acidic or basic? Okay, so this is going to be a very straightforward session, and everything related to that will be very clear to all of you. I would have two oxyacids. Okay, so first of all, what are oxides? Let me give you a brief idea. Anything, any metal, okay, just like if I am having CaO, if I am having CO2, if I am having MnO2, okay, they all are oxides, right? Then what are oxyacids? Oxyacids will be having a certain kind of formula that you will be having any kind of like phosphorus, let's say. Now it's compulsion that you will be having an oxy group. Oxy means you will be having a double bond O, and the acidic group. Acidic group means to be like OH. Okay. So in case I am saying OH, then here this H is going to be the acidic hydrogen. So these are the oxyacids. So any such compound which is having such kind of double bond and OH both together, they are known as the oxyacids. Okay, so we are going to know about that what would be the acidic or basic character of oxides, and of course these oxyacids are acidic in nature because they have the proton, because they have this acidic proton, they will always be acidic. But how their acidic strength gets affected, okay, whether the acidic strength increases or decreases, what will happen in the case, we will be having a discussion on it. Okay, so let's begin with it, guys. Here this topic has been taken from the chapter periodicity. These are the few things that we will be focusing over. We will be focusing over the basic oxides of metals and the acidic oxides of non-metals. So let me tell you guys, if overall if you would see the periodic table, there are so many elements, but out of all those elements you will find that 80% of the elements are metals. Yes guys, 80% are metals and only 20% are non-metals. So the non-metals in the periodic table are very few, and there is a majority of metals, and the metals are usually basic in nature. Okay, but it is not just that we need to know ki, okay, metals are basic in nature. We need to learn about their basic strength as well, whether the basic character increase, decrease, what will happen, who will be more basic, who will be less basic. Okay, if I am having two oxides like Na2O, and I will be having the oxide magnesium oxide, if I ask you which is more basic, then yeah, you must be able to tell the answer. Okay, so we will be focusing on that. So let me give you a brief. Here in the periodic table we have 80% metals and only 20% non-metals. So out of all those metals, they usually possess the basic behavior, and the non-metals usually possess the acidic behavior, but we need to learn about their acidic strength. So here let me tell you guys, so this is our S block element, they all are metals. Okay, S block elements are metals. Even if you would see the D block elements, all these D block elements are also metals. If we also call them transition metals. Okay, so they are also metals. And here if you would see, we call them alkali metals. So yeah, they are also metals. Alkaline earth metals, so in their name also we have the earth metal, so they are also metallic in nature. If you would see the lanthanoids are also metallic in nature. Okay, lanthanoids are also metallic in nature, they are also metals. Okay, so as the size increases, as the molecular weight increases, the metallic character increases. Okay, so here if you would see in this particular part, so as we are talking about the purple part, or I would say here all these species, the purple section, they all are metals, they are all metals. Okay, so in the p block elements, when we go down the group, as the elements becomes more heavy, the molecular weight increases, the metallic character increases, or we can also say as the ionization energy decreases, the metallic character increases. Okay, so yeah, they are all metals. So this is a metal, this is a metal, this is a metal, this is a metal, all they are metals. If you are talking about the non-metals, then who are non-metals? Very few. Only these elements are usually non-metals. Okay, so here you will find that they are non-metals. they are non-matters, and these are the gases, these are the inert gases, okay, the noble gases. And what about these elements? They are basically possessing the metallic as well as non-metallic behavior. They are in transition, okay, they are in transition in between the metals and non-metals. They are basically getting sandwiched, so we can say that they possess both the behavior, that is the metallic and non-metallic both. So usually they have a kind of, they are metalloids, okay, or you can say that because they are metalloids, a mixture of metallic and non-metallic behavior, they will be having more of amphoteric nature, okay. So here the next topic is going to be the amphoteric and the neutral oxides as well. Now the most important points are these two. We will be learning about how the oxidation states affect the acidic character of oxides and oxyacids, okay. Okay, so if I will be having a different oxides, like if I will be having MnO, I will be having MnO2, I will be having MnO4 negative. So what will happen? How the oxidation state affects the oxides and oxyacids, how the electronegativity affects the acidic character of oxides and oxyacids. So let's begin with it. Okay, so guys, as of now I told you, if you are talking about the metals and the oxides of metals, you will find that they are rather than acidic, basic, neutral or amphoteric. The majority of the oxides of metals are basic in nature. Now we need to know S block are also metals, F block, that is the lanthanoids, are also metals, the D block is also metal, the P block elements, many are metals except few which are metalloid. Okay, but many of them are metals. The elements which are lower in there, when we go down the group, which I marked, so such P block elements other than this are actually metals. So how to determine that which is most basic, which is less basic? Guys, it's very simple. First of all, the S block elements, because they have very low ionization energy, they have ns1 electron, so they are most metallic, and because they are most metallic, they are most basic, okay. And then comes our F block elements. As the F block elements, why they are metallic? Because they are having high molecular formula, they are having high molecular weight, their atomic number increases, their molecular weight increases, the size increases, and because of the size increases a lot, the ionization energy decreases, and so therefore F block elements are metallic in nature. Okay, but they comes after S block. Then comes your D block, and then comes your P block. So simply I can say that if you will again see the periodic table, you can see that S block elements are most metallic. So most metallic means most basic. They are most basic in nature. And then comes your lanthanoids, that is the F block elements. Then comes your D block elements, and then comes your P block elements. So relatively P block elements are least metallic relatively, and they are least basic in nature. Okay, so as we are going down, the basic strength decreases. Clear? Now if you are talking about the oxides of non-metals, you will find that usually the non-metals, which I marked the column of non-metals, they are usually acidic in nature. Okay, yes, they actually possess the acidic behavior. Okay, so guys, let me give you a simple question. If I say that you have magnesium oxide and you have a FeO. So magnesium comes in group number 2 and iron comes in a D block element. So this is a S block element and this is a D block element, right? It is a D block element. So simply you can say that S block is more metallic and rather than the D block elements, right? You can compare in such a way. Now you definitely know they are more metallic and they are more basic. So this is more basic and this is less basic. Okay, so this way we can do the comparison. Magnesium oxide is more basic as compared to that of the FeO, if you know that which element belongs to which particular block. Okay, now if there is a comparison between uh, we have a beryllium, magnesium, okay, calcium, then what will happen? We have BeO, magnesium oxide, calcium oxide. Now how will you determine? So guys, where these all elements come, we just need to do that. Okay, so they all comes in group number 2, so they all belongs to group number 2, that is B, Mg, Ka, Sar, Bara. Okay, so they comes in group number 2. So we can simply compare, okay, beryllium, magnesium and calcium. So as we are going down, the size of the atom increases, and as the size of the atom increases, the metallic character increases, the basic character increases. Okay, so as the metallic character increases, the basic character increases. So calcium oxide is more basic than magnesium oxide than beryllium oxide. Now let me tell you, what is this beryllium oxide? Here you can see that I have written acceptor. So basically there are few oxides among the metals and non-metals which are quite different in nature. They could be amphoteric or they could be neutral. Okay, so it is always better that you learn what are amphoteric and what are neutral oxides. Okay, so if you're talking about the amphoteric oxides, the beryllium, this shows diagonal relationship with aluminium. Okay, and therefore it possesses the amphoteric behavior, just like aluminium, which is aluminium and beryllium are having a diagonal relationship. Almost their size charge ratio is same, so therefore they are quite similar in nature. If aluminium can act as a metal and a non-metal kind of a metalloid, so as therefore the beryllium also. So BeO and Al2O3 are amphoteric. Here the gallium oxide and the tin oxide, which is Ga2O3 and Sn2O3, are also amphoteric in nature. Here comes a question, PbO and PbO2. These are the two oxides of Pb. Even I can write it as a Pb2O3. Okay, this is Pb2O3. Okay, so or the Pb3O4, I can say Pb3O4. Sometimes you will be getting this as Pb3O4. So what is this? This is the mixed oxide of lead. What is this Pb3? So basically if you will take a 2 moles of PbO dot 1 mole of PbO2, so this will become Pb3O4. Okay, so this is the mixed oxide of lead. So they all are amphoteric. If this is amphoteric, then absolutely its mixed oxide is also amphoteric in nature. Even the zinc oxide is amphoteric. So you please learn this part. Okay, that which of the specific oxides which possess, they are usually metalloids, okay, which possess the metallic as well as the non-metallic behavior, and so therefore they are amphoteric in nature. Now there are few oxides which are neutral as well. Okay, just like carbon monoxide. Carbon monoxide in its lower oxidation state is neutral, though CO2, if you will be talking about, in its +4 oxidation state is acidic. Okay, so carbon dioxide is acidic, but the carbon monoxide is neutral. Water is neutral. Nitric oxide, this is NO, nitrogen is in its +2 oxidation state, is also neutral. N2O, here the nitrogen is in its +1 oxidation state, this is also neutral, and the oxide, that is MnO, is also neutral. So only these are the few oxides, only the 5 oxides which are neutral. Okay, so in simple we understood key. More will be the metallic character, more will be the basic character, because metals are basic in nature and non-metals are acidic in nature. More metallic, more basic. This is as simple as that. If you compare the blocks, different blocks, S blocks are most metallic, then the F, then D, then the P. Okay, now here you can see that why I have written except, because aluminium, gallium, tin and lead, they all form the amphoteric oxides. Okay, so they are not basic in nature, they are usually amphoteric in nature. Okay, have you seen Al2O3, Ga2O3, SNO and PbO and PbO2? This is the way. So the non-metals are also acidic in nature, and these are the few oxides which are quite neutral. This is what we need to know. Now what happens when we have any kind of acidic oxide? Okay, let's say, let me take an example, acidic oxide. Your acidic oxide could be CO2, could be SO2, could be SO3, any example you can take. So they are all non-metals and hence they are acidic in nature. So if you are having, because why I am telling you all this, because if you will focus here, you will be able to do the questions related to whatever the type of reactions comes in your P block elements, you will be able to do that very easily. Okay, so if you are having any kind of acidic oxide, okay, so what does it do? Any acidic oxide when put in water, so we know that it is acidic and water is neutral, so ultimately the resultant solution is going to be neutral is neutral, this is acidic, so ultimately the resultant solution is going to be acidic. Okay, if you treat an acid with a base, so acid and base, what they becomes? Acid having a pH less than 7, base having a pH greater than 7. So when acid and base combines together, they form a salt. So acid when combines with a base, this forms a salt. So acidic oxide when reacts with a base, it forms a salt. So here is an example. We do have a SO3, which is the sulfur trioxide, when this put in water, so which is neutral. So here we will be getting the, if this is acid, this is neutral, so what they will form? They will form acid. So ultimately what should be the answer? SO3 plus water will form H2SO4, which is an oxyacid, which is an oxyacid. Now here what has happened? If you have taken acid and this is a base, NaOH is a base, so acid and base when reacts together, they form a salt. So what will be the salt? SO3 and NaOH will combine together to form sodium sulfate. Okay, so the basic idea you must have. Now again let me tell you how to determine that an oxide is basic, because if an oxide is basic, when you will put it in water, it will be basic because it is neutral. So neutral is not going to do anything. Okay, neutral is neutral, this is basic, so basic plus neutral gives you base. But base and acid, this is a very opposite combination. So acid, if you will be adding a base, there will be a neutralization reaction and there will be a salt formation. Okay, salt plus water, always you will be getting salt plus water. Okay, so this is neutralization, this is known as acid base neutralization reaction. Here we have an example, Na2O, this is a metal and metals usually forms basic oxides, Na2O. When we have taken this with this basic oxide, when we have taken with this neutral water, we will be getting a base. So very simple to write down the reactions, okay. And if this is basic and we are taking it in the presence of acid, acid base neutralization, there will be a salt formation, simple. Now, what do you mean by the amphoteric oxide? Amphoteric means which is having both the properties, metallic and non-metallic as well, and so therefore possessing and behaving like both of them together. Okay, so what does this mean? So whenever you have the amphoteric oxide, which has a mixed behavior, so ultimately when you will put it into water, water is neutral and this is also acid plus basic, so ultimately you will be getting a neutral solution. But when this amphoteric oxide will reacts with an acid, so here we know that this is having acidic plus basic behavior, okay, acting as both. So if you will be treating this with acid, its basic property will activate and acid base forms a salt. And when you will be doing a reaction with a base, its acidic property comes into action and acid base reacts and form a salt. Let us take an example. I told you PPO, PPO2, SNO, all they are Ga2O3, they all are amphoteric. So here I have taken an example of zinc oxide, which is amphoteric. So when I take zinc oxide, which is amphoteric, in presence of neutral water, I get a simple neutral solution, which is zinc hydroxide. Okay, but when this amphoteric reacts with an acid, so this acid and this behaves as a, in the presence of acid, this behaves as a base. Acid base reaction occur, there will be a salt formation which is ZnCl2. Okay, ZnCl2 is a salt, Zn plus 2 and 2Cl negative. Now, when this is amphoteric and you are treating it with a base, so this behaves as an acid, and if this behaves as an acid, there will be a neutralization and we will be getting a salt which is Na2ZnO2. Okay, that is sodium zincate. So this is the way how the products gets formed. Okay, so this ZNO was giving you NaZNO2, and here you can see that when you were treating SO3 with base, it was giving you sodium sulfate. So basically salt formation will occur. Okay, now what happens with the neutral oxides like NO, NOCO or N2O kind of oxides which are quite neutral. So neutral when put in water, they remain neutral. Neutral will remain neutral, or there will be no reaction. And even these neutral oxides do not react with acid because they are neutral. How they would be reacting? They don't have any acidic, they don't have any basic nature, nothing is there. They are neutral and you are treating them with acid. So there will be no salt formation, that is no reaction will occur. Okay, no reaction will occur. Now here, let me move ahead and let me tell you about one more concept. Okay, so basically as of now we discussed what are the oxides of metals and non-metals. The oxides of metals are basic, the non-metals are acidic, what are amphoteric, and what are neutral oxides. So these are the 4 points that we already covered. Okay, and I discussed with you how you can frame the reactions whenever you will be having such oxides given to you. Now there is what happened, how how the oxidation state affects, how the oxidation state affects the acidic strength. Yani ki if I am having an acidic character in few of the compounds, then how does this oxidation state affects? Basically guys, as I have discussed this point in my previous lecture as well, where I discussed with you the electronegativity and its applications, let me tell you, as the oxidation state increases, as the oxidation state increases, let's say this is A plus 1, A plus 2, A plus 3, A plus 4. So first of all, this element A has to be the same, okay. So same element in different oxidation states, okay. So this is plus 1, plus 2, plus 3, plus 4. So as the oxidation state increases, the size decreases. You agree with this or not? This is the size of an ion now. So here we are having more number of protons and less number of electrons. So Z effective increases and so therefore size decreases. So as the size decreases, size becomes small, its electronegativity increases. Its electronegativity means the ability to pull the shared pair of electron increases, and so therefore the acidic character increases. So we know that as the oxidation state increases, the size of the ion gets smaller, and as the size gets smaller, its electronegativity increases, and electronegativity increases, the acidic character increases. So we can simply say that oxidation state increases, the acidic character increases. So this is a simple relationship that we need to know, but this can only be applied when you are having elements in different oxidation states. So just like here I am having an example of SO2 and SO3, this is also sulfur, this is also sulfur, this is also an oxide, this is also an oxide. So we know that they both are acidic, but how to know, okay, which is more acidic, which is less acidic? So we will be looking at its oxidation state. This is plus 4 and this is plus 6. Okay, so as the oxidation state increases, the acidic character increases. So we can say that SO3 is more acidic in nature. So simply I have given this as the integration method. Okay, integration method says that this is O for oxidation and this is S for state. Okay, so this is an integration sign, and this integration sign is saying ki if the value increases, if the oxidation state increases, maximum oxidation state, the acidic character also increases. Okay, and here it is saying as the oxidation state decreases, as the minimum oxidation state means the oxidation state is decreasing, the acidic character decreasing, or you can say that the basic character is increasing. Simply this is the way how we can say that. Okay, okay, so ultimately the same thing. Acidic strength of oxides is directly proportional to the covalent character, that is the pulling of the shared pair of electron. More will be the polarization, so more will be the oxidation state, acidic character increases. Okay, so here I have taken another example of, you know that chlorine is a non-metal, so they all have to be acidic. Yeah, because it's a non-metal and they all have to be acidic. But how to determine which is more acidic, which is less acidic? We will be focusing over their oxidation state. So here the oxidation state is, I will be taking one session on oxidation state as well. If anybody of you don't know, then you will be able to understand all this as well. So here the chlorine is in its plus 3, here it is in its plus 5, and here it is in its plus 7. So as the oxidation state increases, the acidic character increases. Clear? Here also we have MnO plus 2, here it is in its plus 3, here it is in its plus 4, plus 5, and this is in its plus 7. Okay, so as the oxidation state increases, the acidic character increases. Otherwise, we usually know this is a metal, Mn is a metal. Okay, or metals are usually basic in nature. So we can say that basic in nature. So we can say that the oxidation state increases, acidic character increases, and the basic character decreases. We can say that basic character decreases because acidic and basic are opposite to each other. If any of the question asks you about the basic character, so if acidic is increasing, the basic is decreasing. Okay, and here you might know that bache MNO I told you what is MNO. MNO is a neutral in nature. Okay, so here MNO is a neutral in nature. So we are going from neutral to more basic, neutral to neutral to acidic, neutral to acidic. Okay, so this is it. Now here again the same thing you have to do. So oxidation state, in every question when we have the same elements, we can compare them only on the basis of the oxidation states. So as the oxidation states gets changed, the acidic character increases. Now here I am having an example which we have different metals, like this is MgO, Al2O3, SiO2, P2O5, SO3, Cl2O7. So can we answer on the basis of oxidation state? No, we should not, because different elements. Okay, so here the oxidation state is not a right method to compare all of them. Here we will be comparing on the basis of what are the elements. So here you know that this is magnesium, belongs to group number 2, that is S block element. This is aluminium, we know that this is amphoteric. I told you amphoteric, a list of amphoteric you please remember separately. Silica, this comes in group number 14. Okay, this is a P block element. This is phosphorus, again this comes in group number 15. This comes in group number 16. This comes in group number 17. So ultimately they all are P block elements. So we are going from S block to group number 13, which is amphoteric, to P block, means we are going from left to right. So as we go from left to right, we are going from metallic to non-metallic. So metallic one is going to be basic, this aluminium is going to be amphoteric, and they all are going to be acidic. And we know that as we are going from left to right, we are getting more metallic. We can say that the electronegativity increases, right? As we move from left to right, the size becomes small, the tendency to pull the shared pair of electron increases, and hence the acidic character increases. Okay, so this is again the application of electronegativity which I discussed in the previous section. Okay, just before that I have taken a session on electronegativity, we discussed on that. The electronegativity increases, the acidic character increases. So left to right, so electronegativity is a property which must be applied on moving from left to right. This, you please don't apply the electronegativity concept on moving from top to bottom. Only for left to right we should apply electronegativity, because as per Pauling, this principle is more valid for along the period. Now the last point is, guys, what about the oxoacids or oxyacids? Both are right. Okay, oxyacids. So oxyacids, I told you that there must be an yeah, okay, fine. This is oxoacid basically. There is no oxy group. There is only oxyacids group. Here we have this. So I could have HOCl. I could have Cl double bond OH and H2ClO4. I could have this kind of structure. This is H2ClO4. Okay, so this is oxoacid, and we can say that this is oxyacid, because here we have the acidic group and we have the oxo group as well. So if I have to compare between this and this, how I will compare? So this is also having oxygen, this is also having the OH group, this is also having the OH group, this is having the chlorine, this is also having the chlorine. So here when we have the same element, then we will compare on the basis of oxidation state. So here the oxidation state of this chlorine is +1, and here the oxidation state of chlorine is plus ka 7. So here +7, because the oxidation state increases, the acidic character of this is greater than this. Are you getting my point? So if we are having a comparison between the same central element, then we will be focusing over their oxidation state. But if you would compare in all these elements, in all these questions, if you will be comparing from this to this, you will find that this is fluorine, this is chlorine, this is bromine and iodine. They all are different elements, right? And So different elements. So how to examine? Guys, are they directly bonded with the fluorine? This is the acidic hydrogen that we have to give. This is the acidic hydrogen that we have to give. So how will you determine? So we have to look for the factor of this fluorine, chlorine, bromine and iodine. So here comes your organic chemistry concept. You know that the fluorine, because it is highly electronegative, this will be having more pulling nature, this will be showing the minus I effector. As this will be showing you the more minus I effector, so here the negative charge will get more stable over the conjugate base. So just like that, what you need to form? You need to form H positive plus OF negative. So this negative charge must be more stabilized. So whosoever will form a stable conjugate base. So this is your conjugate base, and so therefore whosoever will form a stable conjugate base is going to be most acidic. Okay, now let's have a look. This is H positive, this is OCl, this is H positive, and this is OBr, this is H positive, and this is OI. So in which case this negative charge is extra stable. So here the fluorine is having strong minus I effect, and because of the strong minus I effector, this negative charge, this conjugate base is more stable. This is more stable, and so therefore it is most acidic. It is most acidic. But if you would see here, the electron pulling power of fluorine is less than the bromine, and the iodine will not even pull the electron towards itself. And so therefore the stability as we are going down, the stability of conjugate base decreases. The stability of conjugate base decreases, therefore the acidic character decreases. Okay, the acidic character decreases. So this is as simple as that. So please very conscious that among what kind of elements you are comparing. Okay, so guys, after this I will be coming with one session where we will be having focus over the questions related to the complete chapter periodicity. So let's wait for that. Okay, the session will come soon for you all. So you please apply all the questions that I will bring for you with detailed explanation. So thank you so much guys. If you really like this session and you find that the session helps you in any way, then guys please do subscribe, do hit like and leave your comments in the comment section, so that we need to know what you're thinking about all the sessions. You want them or not, what you want. Okay, so please guys try to fill that gap by your comments, and do follow me on an academy, because as I am an academy plus educator and I am teaching you all there, I do have 127,000 followers, those who are already learning from me. So why not you do join me by just a click away. You can follow me on an academy and be a learner there and start your IITJEE preparation. See you guys. Thank you so much. See you in my next video.